Our I can statement for this video is, I can solve and explain problems with large numbers and decimals. And actually the focus today is on word problems. So we're going to have word problems with large numbers up into the millions and decimals, so numbers to the right of the decimal place. We're going to be able to solve them and explain them by the end of the lesson. As we look at the first part of our lesson today, there are some directions and some reminders. So we've got place value problems, so we're going to be focusing again on place values. As a reminder, you all have your place value chart, and we have highlighted or shaded in the ones place to show that there is symmetry around that. So if I go to the left, I have tens, hundreds, thousands. If I go to the right of the decimal right there, I've got tenths, hundredths, thousandths. And the pattern continues the same. 10,000s, 10,000ths with a THS, 100,000s, 100,000ths. You also have a page in your math book, page 93, that shows the groups of three. So this group of three is considered your ones. Remember, we don't say those out loud. We don't say the place value. This group of three is your thousands. So when we see this comma right here, we would say thousands. And here's your millions and your billions. So if that helps you, take out page 93 to remember how to say the word names out loud, or the number names. Let's take a look at the page today. It says, when solving word problems, you need to pay close attention to place values. Remember to only add and subtract like place values. Like place values. So that would be like subtracting ones from ones, thousands from thousands, millions from millions. Everything must be lined up. And our last video, we showed that if you line up the decimal points, every other place value is going to line up perfectly. And remember, if you have a whole number like 321, the decimal point can only go right at the end, right after the ones place. If we happen to see the number 321 and we put it right here, that would change the number. It's no longer 321. It is 3 and 21 hundredths, which is a completely different number. So I'm going to read aloud the directions now, and I want you to really, really focus on place value. Some of these numbers are written in word form, and we're going to need to think about them in number form. Large creatures. There's my heading. Dr. Magnuson is a scientist who studies whales and sharks. Well, those are large creatures. That's why it's about that. She and many other scientists think that sharks appeared on Earth about 395 million years ago, and whales appeared about 70 million years ago. They think that human beings appeared about, I got to figure out how to read this number. So there's my ones, thousands, millions. All right, so this is 1,750,000 years ago. I'm going to read that again. They think that human beings appeared about 1,750,000 years ago. Well, as you can see, I have three distinct numbers here. I've got 395 million years ago, 70 million years ago, and 1,750,000 years ago. I need to rewrite all of those in number form so that I can add and subtract them, or whatever the problems want me to do from here. So over on the side, I'm going to rewrite these numbers in number form. Well, in 395 million, I see that 395 goes together. And if I look at my place value chart, I see that over here we have millions, so I would put a comma, and then I'm going to have a bunch of zeros in the thousands, so 0, 0, 0, and then 0, 0, 0. So in order for it to be 395 million, I need 395 here, and then zeros and zeros, so a total of 6 zeros. So there's my number, 395 million. The next one says 70 million years ago. And I can kind of use the same information. I don't need to look at my chart again. I know that if it's going to be 70 million, 70 million is going to be a 70 in the millions place. So I would need 6 zeros after that. This being the ones, so ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, and up here 100 millions. Notice how I also lined up these place values. Even though I'm not doing anything with these numbers yet, it really helps me see that they are lined up and how big they are compared to each other. My last one is already written out as in number form, so I'm just going to copy it down. I see that I have 1,750,000 years ago. In this lesson, I'm not going to do the subtraction with you, but I am going to help you set them up for a few of these problems, so I want you to follow along closely. About how much longer have sharks been on Earth than human beings? So I'm comparing sharks to human beings, and I know that 395 million years ago is the sharks, whales are 70 million, and humans are down here at 1,750,000. So I'm comparing them. They want to know how much longer is 395 million than humans, so I would set up a subtraction problem. 395 million minus 1,750,000. And I would have to write that vertically over here or maybe on another piece of paper and then subtract, remembering to line up the place values. All right, there I've set up my problem. And again, I've lined up my place values all the way down. My millions place is lined up. My ones place is lined up. My commas line up. So then I know that I'm going to get the right answer. I just have to know what I have to do. About how much longer? They want to know how much longer. So again, I am going to subtract. Since I am comparing them, I am not putting them together. Just as a reminder for this problem, I noticed that I have a bunch of zeros, so those are going to be easy to subtract. But then I notice I have a 0 up here and a 5 down here. If I have 0 in the 10,000s place, I can't take away 5 in the 10,000s place, or 50,000. I'm going to need to go all the way over here and start ungrouping. So that would look like this. I have 4 million left. That gives me 10 in the 100,000s. But I still need to move it over more. So I'd end up with 9 in the 100,000s and 10 in the 10,000s place. If you look through these problems, I'm just going to go through very quickly. I'm not going to set up any more for you. If you look through these problems, about how much longer, they're comparing again, so I'm going to be doing subtraction. And down here, about how much weight does a blue whale gain? So again, that's going to be subtraction. Down here, about how much longer? So again, we're comparing, so it's going to be subtraction. Number 5, how much longer? So again, these are all going to be subtraction. We just have to identify the correct numbers and line up the place values correctly. Your resources, again, you've got this sheet that I've given you, or you have page 93 in your book to correctly identify the place values. On the following page of your work today, you are also working with place values in the exact same way, but you'll notice that some of these are addition problems instead of subtraction. So how many kinds of moths and butterflies are there altogether? The key word there is altogether. That tells me that I'm going to be adding them. So if I think of it as a math mountain, my moths and my butterflies are at the bottom, and my total altogether is at the top. How much larger is the Queen Alexandra butterfly than the pygmy blue butterfly? So again, this time, let's talk about how much larger. So that's going to be subtraction. Let's see. The next problem says, how many centimeters does the monarch caterpillar grow? So that's starting at the beginning. This is how small it is at the beginning. This is how big it is at the end. It wants to know how much does it grow. So that's going to be an amount of change, which is going to be subtraction. I'm going to take the big amount minus the small amount. And which egg is smaller? How much smaller? I see 2 question marks, so that means I'm going to have 2 answers. One is going to be which egg is smaller, and the next one is how much. So that's going to be a subtraction problem. Notice that you have, both of them are in centimeters, and you have different place values here. So make sure you correctly line up the place values using the decimal to help you. The last problem is going to be writing a word problem. Make up an imaginary animal that is very large or very small. So if it's very small, it needs to have a decimal. If it's very large, it should be somewhere in the millions. Give it a name. So you're going to name your animal. Then decide on a length or height and weight. Then write an addition and subtraction word problem about the animal and the measurement you decided on. Have fun!